Hi all, I'm back with another project. So this project is a machine learning case study, basically a classification task. So as you can see the topic here, I opened this Kaggle website and the topic name is San Francisco crime classification. So basically this topic, this whole agenda, the agenda of this data set is to, classify the type of crime given any data point. So this competition happened 6 years ago, and we can see the number of teams who participated in this competition. As a challenging project, I have taken this and referred, learned, and implemented in my own way. So let me just discuss that throughout this uh, video. So the description of this topic case study is that San Francisco, although we have known about it, we have known about the city by its various tourism spots. Even that, we also need to know that San Francisco is a place where crimes usually occur on daily basis. So in this data set, we get to see that the SFPD, San Francisco Open Data, which is also interlinked with the SFPD, that is San Francisco Police Department, by observing various crime reports that happened 12 years back, in the sense from 2003 to 2015. So we must also subtract this 6 years, right? So they have open sourced this 12 years of data in order to find patterns, similarities, and classify the crime type. This helps the police department to automate several tasks, right? And yeah, this is a bit about the description of the data. Since you are dealing with classification problem, we don't have one or two classes to be predicted, but we have several categories or classes to predict, and that's why we also must go with the performance metric. So in the evaluation tab, we see the performance metric that we need to follow while solving this task. So we have multi-classes, and that's why we use a multi-class logarithm loss, also known as cross entropy. To talk a bit about that, the formula of the log loss, multi-log loss, is this. We can see the notation. Here, capital N stands for number of observations, number of data points. And capital M, it stands for number of classes. So these are the two things. And Yij, it's either 1 or 0. I'll explain how it is. 1, if any of the observation belongs to J category. So we have multiple classes, multiple points. If any of the point belongs to any of the class label, then the value of this is 1. Otherwise, it is 0. Now, this Pij, it is actually the probability of the prediction. Pij stands for predicted probability that the observation belongs to class J. So when we do modeling, when we predict the category of a point, we also get a prediction probability. So that is nothing but Pij. So by substituting all this in this formula, we get a log loss value. And we must ensure that this loss is minimum. So that's about the performance metric. And we have this format of the submission. This is something which we have to come once we solve the entire task. Now I don't think they will give prices because it happened 6 years ago. And coming to data, let's see the data. So the snippet of data looks something like this. We have time, we have uh, we have this column category, something which we have to predict, and we have the description, the third column. We have a day of week, when on which day it occurred. It is Monday, Tuesday, 7 days, right? We have 7 days. And district, police department district, in which police department the crime happened. Resolution, is it resolved or not? Address of the crime that happened, and the coordinate values. So here X stands for longitude and Y stands for latitude. Unfortunately, because this is given in the form of zip files, we can't view the data here. But what you can do is you can simply download this data in your system. You can use Kaggle API by by just creating an account and coming to this San Francisco problem. You can easily get download the data. I guess there is some way to download. Yeah, here we have. So we can simply download it by copying the API credentials of our account, and we can download it in your notebook also. Like if we just this is a Linux command, and if we can just put this command on the notebook and execute, data downloads in your working directory, and likewise you can extract the files and work with it. All right, this is it for this video, and we'll discuss the EDA part in the next video. All right.